So dear students, in the last class I have discussed about the properties of even and odd function, and that will be very helpful for this section, that is in sine and cosine series. When you want to expand a function f of x in terms of Fourier sine and cosine series, then the concept of even and odd function is very needful here. Okay, so I have discussed in the last class in detail about even and odd function, that is basically the 10 plus 2 level, your 10 plus 2 level concept. Okay, so now let me discuss about sine and cosine series. Okay, Fourier sine and cosine series. So as you know, I have discussed earlier the property of the integration property, basically the definite integration property of an even function or of an odd function. Okay, so let me take that f of x is a function. Now if you want to integrate this function within a certain limit, that is minus L to plus L, then you will get 0 if f of x is odd. Okay, and you will get just 2 integration 0 to L f of x dx if f of x is even. If f of x is even. Okay, and this property of integration property will be very helpful for this topic. Now what we are going to do here, we are going to expand a function in terms of either sine series or cosine series. Previously what we have done for any function f of x, we have the Fourier series. Any periodic function f of x, we have the Fourier series that a0 by 2 plus summation n is equal to 1 to infinity n cos, in terms of n by x by L, you can write, plus bn, okay, and sine n by x by L. So this was our Fourier series with certain coefficient a0, an and bn. But what is happening here, you can see the Fourier series is in terms of sine and cosine both. Okay, any periodic function f of x can be expanded in terms of sine and cosine series. But what we are going to do here, what we want to do here, either sine series or cosine series. That means either an is equal to 0 or bn is equal to 0 should be. Okay, so in that case you will get Fourier sine series or cosine series. And what we have to do in that case, and how we will get this sine and cosine series in that case, let me discuss with you. Okay, so suppose we have a function, or a function f of x is given. Suppose the function f of x is given within the interval 0 to L. Within the interval 0 to L. But what we are going to do here, we are going to expand this function f of x in terms of Fourier series in the interval minus L to L. Suppose the function is given within the interval 0 to L, but we want to expand the function f of x within the interval minus L to plus L. So we need to define the function f of x from minus L to 0 also, because this is not given. The interval minus L to 0 is not given, only 0 to L is given, but we need to sketch the function or draw the function within this interval minus L to L. So what you can do, you can just put for this interval f of x is 0. You can do it if you want. If your purpose is only to expand the Fourier series in minus L to L, and if f of x is given within the interval 0 to L, then you can put f of x 0 for minus L to 0. Okay, so your purpose will be fulfilled in that case. But here our goal is different. What we want to do here, we want to expand the function f of x not only in the interval minus L to L, but we want the function either sine or cosine. We want the expansion, or we want the series in terms of either sine or cosine. So we have to fulfill two conditions. First, what we have to do, we have to sketch the function f of x in minus L to 0 in such a way that the Fourier expansion in the Fourier series, there will be only sine terms or cosine terms. So how you can achieve this? You have to draw the function f of x within the interval minus L to 0 such that the function is converted either odd function or even function. So let me give you an example that you can understand better. Okay, so let me give you the example also. Suppose we have a function f of x. Okay, suppose we have the function f of x. Okay, f of x is equal to x, very simple function, let me take. Okay, suppose we have function f of x is equal to x within the interval 0 less than x less than L. Suppose this is given. So what will be the sketch of this function? The sketch of this function within this limit 0 to L, here is f of x and here is x. So it will be, and if this is L, then the sketch of this function will be just this kind. F of x is equal to x, that means y is equal to x. Okay. Now, if you want to sketch this function for minus L less than x less than 0, that is, suppose this is minus L, then what you have to do? If you want to get this function as odd function, then you have to draw this graph such that it will be symmetric about the origin. But if you want to get this f of x as even function, then you have to draw this function in such a way that it is symmetric about y-axis, that is f of x. So first let me draw this function in such a way that f of x is even. Suppose we want f of x is even. So if f of x is even, then it should be symmetric about y-axis. That means the plot of minus L to 0 will be this kind. Now it is even function. But if you want to get it as odd function, okay, then what you have to do? Suppose this is our f of x and this is our x, f of x and x, and you need that f of x is odd, suppose. Okay, so this plot will be same always. So this is given just. Okay, now we have to convert it as odd function, so we have to sketch the graph in such a way that it is symmetric about the origin. So what will happen? So if this is minus L, then the plot will be something like this. Okay, so first what is given? A function f of x within a certain interval, within the half interval you can see, and that's why sometimes this is called half range series also. Okay, so this is given within the half range, that is 0 to 0 x less than L. Okay, but what we need, we just convert this f of x either in even function or in odd function. Okay, so if you convert it as an even function, then you can see that the Fourier expansion of this will be the cosine series, that is only cosine term will be there. If f of x is odd, then only sine term will be there. Why? Let me analyze again. Why when f of x is even, why we will get only cosine term, and when f of x is odd, why we will get only sine term? So if you want to expand this function as a sine series or cosine series, accordingly you have to sketch the graph, or you have to convert the graph as even or odd. Okay, so let me see you. Okay, so we show you that suppose we have Fourier series f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity n, okay, cos n pi x by L plus bn sin n pi x by L. So this is our Fourier series where n and bn and a0 are constant, and the coefficients are something like this. So we have a0 is equal to 1 upon L integration minus L to L f of x dx. Okay, an is equal to 1 upon L integration minus L to L f of x cos n by x by L dx, and bn is equal to 1 upon L integration minus L to L f of x sin n pi x by L. Okay, so these are the Fourier coefficients. Now you can see if f of x is odd, suppose you have just f of x is, suppose first let me take f of x is even. Suppose f of x is even. Okay, so what will happen? What will be the coefficient a0, an and bn? Okay, so let me write it in another page. Okay, suppose first case 1, let me take that f of x is even. So what will happen? What will be a0? So we have a0 is equal to, you can see 1 upon L integration minus L to L f of x dx. And according to the property of even function, you know, I have discussed earlier that minus L to L f of x dx is equal to 2 integration 0 to L. So it will be just 2 by L, okay, integration 0 to L f of x dx. So this will be our Fourier coefficient a0. Now what is an? So an will be 1 upon L integration minus L to L f of x dx, and sorry, f of x into cos n by x by L into dx. Okay, f of x into cos of n by x by L into dx. And you know, this is even function and this is always even. Here given f of x is even and cos always even. So even into even is again even function. So it will be just 2 by L integration 0 to L f of x cos n pi x by L dx. Okay, so this is a. And what will be bn now? So bn will be just 1 upon L integration minus L to L f of x and sine n pi x by L into dx. Okay, and here f of x is what? F of x is odd function, even function. It is given the f of x is even function, and sine is always odd. So even into odd will be odd function, and from the property, you know, minus L to L odd function into dx will always be 0. So you can see here bn will be 0. So if your bn will be 0, then this term will be vanish, okay. So you will end up with only this constant term plus this cosine terms. So this will convert it you for cosine series. So what you will get? So you will get f of x is equal to just a0 by 2 plus summation n is equal to 1 to infinity a n cos n by x by L. So this will be your Fourier series. In that case, you will end up with this now. Okay, so this will be just cosine series. Okay, so if our purpose is this, so you have to sketch this f of x in such a way that f of x is converted to an even function within the interval minus L to L. Okay, now if f of x is odd, then what will happen? So this will be our case 2 if f of x is odd. Okay, now if f of x is odd, what you will get? You will get just a0 is equal to 1 upon L integration minus L to L f of x dx is equal to 0. Okay, because this is odd function, so odd function will be always 0. And what will be your an? 1 upon L integration minus L to L f of x into cosine of n by x by L into dx. And this will also be 0 because f of x is odd and this cos of n by x by L is even. So odd into even is always odd function, and minus L to L odd function dx will be 0. So the only term that will survive is bn, because here 1 by L into integration minus L to L f of x sine n by x by L dx. Okay, and this is odd function, this is given, and sine is always odd function, and you know odd into odd is even. So you will end up with 2 upon L integration 0 to L f of x, okay, sine n by x by L dx. So you will have bn and a0 and an are 0. So you can see from here, so your this term will be vanished, and you will end up only this term. So there will only be sine terms. So when the function is odd, then your Fourier series will be converted into a purely sine series. So you will get just f of x is equal to summation n is equal to 1 to infinity bn sine n by x by L. Okay, so you will end up with this series. Okay, now let me take an example, okay, so that you can understand this theory part. Okay, so this is your example. Okay, so here a function f of x is given within the interval 0 to 1. Okay, function is given within 0 to 1, and we have to expand this function as Fourier sine series and cosine series. Okay, and in C part you can expand it as ordinarily, that is sine cosine series that we have discussed earlier. So you can do it your as homework. So I'm going to discuss here only this A and B part. Okay, So what you have to do? So let me first sketch this function f of x. Okay, for case 1 or for the a part, that is Fourier sine series. And you know, for Fourier sine series, what we have to do? We have to sketch this function f of x such that it will be odd function, that is symmetric about the origin. Okay, so f of x is equal to 1 for 0 to half. So let me sketch this function. So this is our f of x and this is our x. So f of x is equal to 1. So let me take this as 1 and this is our half 1. Okay, this is minus half and this is minus 1, suppose. We have to draw here, and what you have to do, just, so for 0 to half it is 1, so it is constant. Okay, and then it will be 0, something like this. Okay, so now if you want to get it as odd function, then you have to draw so that it is symmetric about the origin. So you will get this kind of situation, this kinds of, okay, you will get this kinds of situation. So this is symmetric about the origin. Okay, this is symmetric about the origin. Okay, so now what you have to do, you have to just draw the Fourier sine, you have to just expand at Fourier sine series, because this is now your odd function. Okay, so for odd function you have a0 and an is equal to 0, so you will have bn, and bn will be just what, that will be 1 upon L, let me take it directly, that 2 upon L integration 0 to L, okay, f of x into sine n pi x by L into dx, and here L is equal to what, here L is equal to 1, so here L is equal to 1. Okay, so for L is equal to 1, for L is equal to 1, you have bn is equal to 2 integration 0 to 1 f of x into sine n pi x into dx. And what is f of x? F of is equal to 1 for 0 to half, so it will be just 2 integration 0 to half, okay, 1 into sine n pi x dx, because for half to 1 it is 0. Okay, so your bn will be just 2 into integration sine n pi x, that means integration of sine x is cos, so it will be a minus cos of n pi x divided by n pi, and the limit will be 0 to L by 2. So your bn value will be just 2 by n pi, okay, n pi into, if you put 0, so cos 0 is 1, minus if you put L by 2, so it will be cos n pi by 2. So you will get this 2 by n pi. Now if you put n is equal to 1, 2, 3, 4, you will get just the values of bn. Okay, and your series will be here, your series will be just you can do it yourself. Okay, so your series will be here, n is equal to 1 to infinity bn sine n pi x by L, and L is 1, so it will be just simple bn sine n pi x. So you will put n is equal to 1, 2, 3, you will get all the bn value, and n is equal to 1, 2, sine pi x, sine 2 pi x, sine 3 pi x, you will get. So do it yourself. Okay, so you will get the series. Similarly for cosine series, what you have to do, you have to convert this. Suppose this is our f of x is equal to 1. Okay, so this is our graph, so this is half and this is 1. So what you have to convert this graph as even function, and that will be what, that will be symmetric about the y-axis. So it will be something like this. So this will be your minus half and this will be minus 1. So this is the graph that f of x is even. And what you will get, bn is equal to 0, and a0 will be what, 2 by L is 1, integration 0 to 1, okay, 0 to 1 f of x into f of x dx only. Okay, and your f of x is 1 simple, so it will be 2 into 0 to 1, 0 to half, okay, into dx, because for 1 to 0, a half to 0, the function is 0, so it will be just 2 into half, that is 1. So your a0 will be 1, and your an will be just 2 upon L integration 0 to L, okay, f of x into cos n pi x by L dx, and L is 1, So you will get 2 integration 0 to 1, f of x is 1, so 1 into, and this is half, and it will be cos n by x simply, and that will be 2 into integration of cos, that will be sin n by x divided by n pi integration 0 to half. So it will be just 2 upon n pi into sin n pi by 2, sin n pi by 2. Okay, x is equal to half sin n pi by 2. Okay, thank you.